Hello, I'm Roman, and welcome back to the series of videos Neural Networks from Scratch, where we using this book, Neural Networks from Scratch, in Python, but we are writing everything with the Golang. And in the previous video, I implemented the stochastic gradient descent optimizer, and right now we're going to use it. Well, I mean, we actually started to use it, and we see that, well, there is a method called update params, but we didn't check the results yet properly. And the next thing we're going to do here is implement this example, and it uses the spiral data once again. And I've been remembering that the spiral data in my example returns a two-dimensional array, and I've been thinking that probably it's not the last time I'm using this function. So I'm going to, and I mean, anyway, I'm writing everything using the Go num. So it makes sense to just return the dents right from this one. So this is what I'm going to implement. So instead, well, first I will make a copy for now. And just to make it easier for me to refactor. So what I'm going to do, I'm going to return the mad dance, which is go num. No, you cannot. Okay, let's do it like this. So then what? Then we're creating the x, which in this case will be the new dance, right? Where the number of columns is number of samples multiplied by number of classes and 2 columns, right? So I don't need this anymore. Then what we're going to do, we're going to through all of the classes and generating some stuff, like art values, t values, it doesn't matter. The only thing that is going to change in this one, so here instead of, what is it, ix0, and here I need a value, and the value will be this one, right? This one. Then we're going to do the same for the y value, and I'm checking the only difference is this one. Okay. And return x, y. I think I'm going to return this. We declared not enough arguments. Oh, correct. We need to specify nil because we wanted to create, well, I want the dance method to allocate the data, because if we take a look at the documentation, it tells that if data equals nil, a new slice is allocated for the backing slice. So this is what I need. Okay, right now it works. Then oops, not this one. Wait, I changed the key mapping in my NeoVim config, so I'm a little bit not confused, but just, you know, I need to get used to it. So what I need to do, actually, these will be the inputs, the one that I'm declaring here. I don't need to make this copy, so that should work. Okay, that works. do I need to do the same for... I mean, I have the second one and scatter it's to the plotting. I have the vertical. I mean, okay, let's do it. Let's do it to be consistent. No, I don't have. Okay. Where is it? This one. So again, I'm changing, I'm returning dance, right? Then we're creating new dance, and here it's again samples, classes, and 2 again. Don't need this. So right now we need to set the value. So it will be, it's set, right? So this and like this, right? Yes. Then again set, don't need this. Not enough arguments. Okay, yeah, the same mistake. Okay, once I will use it, I will have the compilation error, but for now, let's leave it like this. Oh, I actually have it. Same change. This is the inputs. Do I have more? Okay, I don't have more errors. Okay, so are we good with this one, right? So the next thing. Okay, so right now we're going to test another model. Recall that the layer object contains its parameter, weights and bias, and also the state. Okay, let's make an Y by 64 densely connected neural network, one hidden layer with 64 neurons, and use the same data set as before. So we'll have the dense layer, ReLU activation, then we have the output layer, we have the loss activation, and then create an optimizer, and then perform a forward pass of our sample data. Okay, so how to call it? Run model v2. No idea why, but okay. X and Y we taken from data set spiral data, and I think that's the same 100 by 3. We have the data. Then we need to create the model. So creating the first, which is layer, we need to initialize it. We have 2 inputs and 64 neurons. I have the activation one, and that is ReLU activation function. Then I'm creating the output layer, which is again the layer struct. I need to again initialize it, and here we have 64 inputs and I think 3 outputs. Correct. And then I have loss activation, which is actually in the classifier. Yeah, they're all not used. run model 2. Okay, so they are not used, and we create in the optimizer, which is this one. Okay, so we prepared all we need. And what we're going to do, then we're going to do a forward pass. So we take in the forward pass, then pass in the X. We take in the activation function, and we take in the dense1 output. Then we doing the same for the second layer. And right now we take in the output from the activation, and then we using the loss activation forward that takes dense to output, and I won't name it because it's not Y, it's basically target classes. Oh yes, it's smaller, right? And for, oh, really? Okay. Have it in two places. Okay. Okay. For what? Here, and I think should be in another place. Yes, forward. Oh yeah, and that returns to us loss value, which we go into print. Print first loss and loss value. Then we calculate in the accuracy, and I will calculate it all at once. And that's calculate accuracy. And for the accuracy, we take in the loss, activation, output, and target classes. And then the same accuracy. Okay. Next, we do our backward path, which is also called backpropagation. And, well, we're doing it in the reverse. So we have the loss activation, we call in the backward method that takes the outputs and target classes. I think I need to call it target classes everywhere. Then again, we go in it in reverse. So the next thing is backward for the inputs. Then we take in the first activation backwards, we take in dense to the inputs, right? And the last thing we calculate in the backward method for activation the inputs. Does it make sense? Kinda it is. So then what we're going, we take in the, we're updating the params for the first one and for the second. And what it tells, this is everything we need to train our model. Okay, I will try to run it in case it crashes. No, it doesn't crash. Okay. This is everything we need to train our model, but why would we only perform this optimization once when we can perform it lots of time by leveraging Python's looping capabilities? Well, again, I'm not using Python, I'm using Go, but I mean, most languages have looping capabilities. We'll repeatedly perform a forward pass, backward pass, and optimization until we reach some stopping point. Each full pass through all of the training data is called an epoch. In most deployment tasks, a neural network will be trained for multiple epochs. Through the ideal scenario would be to have a perfect model with ideal weights and biases after only one epoch. To add multiple epochs of training into our code, we will initialize our model and run a loop around all the code performing the forward pass, backward pass, and optimization calculation. So we have, and then we have one forward pass, and we will print periodically. Okay, let's do this. So I'm going to create constant number of epochs, I think like this, and it will be 10k. Then for epoch equals to 0, epoch, correct? Epoch, right. Epoch less than number of epochs, yes, epoch plus plus. Then we move in all of this here, right? And if epoch divided by 100 without a leftover, is it called like this? Equals to 0. That should be like this. The only thing I need to change is epoch and epoch. This gives us an update of where we are, the model's accuracy and loss for every initial. We can see consistent improvement. Okay, let's try again. I'm not sure. Yes. It feels like it doesn't update the weights, right? Because I think that's incorrect, because I need to subtract from the weights and biases, right? And I am subtracting from this. Oops. No, wait. So there is no change, but it should be. Okay. Wait. Okay. First this one, then okay, because I need to change weights and biases. So this is actually this, right? Yeah. Then, oh no, wait. Let me think. We'll change it again. I'm just thinking maybe it changes the copy. But no, I mean... No, here that was correct, so I changed the... I'm changing the due weights. And okay, the only way to test it is to see the what was before, for example, for the weights. Right, and then check what was after. Do we have a difference? Okay. It's hard to compare. Actually, I need to check it not here. I should check it in the place where I call it, right? It's actually here, right? So it's then 1 and then okay. Okay, it looks like there is no change. Okay, for example, the last 0085, 0085. So they're not changed. Okay. Okay. Oops. What's called VA? Oh, okay. And still no. Okay, td print mat formatted weights. Okay, it's just because it always 0. How it can be always 0? How it can be always 0? Okay. Okay. Then okay, it has some values, right? This one, it has some values. and it has some. Okay. Then it has some values. You know what the error is? Optimizer new. Still. Okay. Once again. So they have the value, right? Okay. Have some values in the weights. We have some values here, some positive, some negative. And they should be different. The question is, okay, so I'm checking the, what is it? Layer weights. What is it? 0053. Okay. Call then swan weights. Okay. Call then to weight. I mean, I should see some changes, right? But it's kind of the same every time. And or it just gets worse. Okay, what if I will try to change the learning rate from something smaller? Will it make a difference? No. Okay, let's, I don't know. There's some value is layer. Not here. In main. Oh, I can test it. Okay, for example, I have some value at, for example, dense 1 weights at, I don't know, 10 2. Right? And then I'm going to print value and same 10. They should be different. Really? Oh, it's weights. Okay. Okay. Take this one. Weights are they're changing, right? For example, the difference. Let's print the difference then. So the d weights is always the same. Maybe I made a mistake there. No, I mean I'm creating the every time. I mean the step is always the same, right? But it doesn't move. Wait, where? No, but we're actually decreasing the params in this. But why it has no very, very interesting. Maybe the problem with the data that I'm generating. No. Okay, let's take a look at. Okay, let's try again with a much smaller learn rate. Maybe. Maybe I need actually bigger. Okay, let's try something like this. Now, maybe the issue that I'm training not long enough with this. Let's try to, I don't know, 10 times. Oh. It's interesting that in the beginning I have some changes. But then it goes. Let's. One. So I actually see the progress, but for some reason it stops on. I don't know, maybe I'm calculating the accuracy incorrectly. Let's take a look. So I have the target classes. Okay. Deeper. Yeah, I have target classes and I have the prediction classes, right? And they should I don't know, I need to Okay. Okay, so we have the, how I did it? We have the target classes. Okay, and I have the predicted classes. I mean, technically, the predicted classes should change over time, right? For example, if I have 100, they have to change somehow. Yeah, I see the changes. Okay. So the model actually trains, but hmm. Hmm. So at some point, it just started to predict one class every time, which doesn't, I mean, it really doesn't look right. Okay. So what it would mean? I could overtrain. The only issue why it kind of started to change it, I mean, it changes the classes. So that's, you know, more or less prediction classes, more or less good. But if I mean, I have a pretty small learning rate, so that's still interesting. So, I mean, there could be a couple of things. The first one is the problem is in the data that they generated, and maybe I actually, I don't know, maybe I actually refactored it incorrectly. Oh, no, I'm not sure. Let's take a look again. I'm using the spiral one, right? I mean, this is more or less the same. I mean, I still can... Well, I can... I mean, I can check it, right? This... main... Scatter... Actually, we can do the conversion back. I mean, this is interesting how at some point... No, it... Well, for example, here, it's... Okay, what if I... Maybe I just don't need to train this model that much. Okay, the last thing for today, and I will take a break. So we have the prediction. Okay, so it, you know, it doesn't change the needle too much. Okay, let's do the 3 epochs, right? So when we're trying to understand. Two, 5. I mean, it changes it a little bit, but okay. Okay, let's use the 1. Maybe that will make a drastic change, but looks like not. I mean, it's still, they are like on every time they're still evenly distributed. I mean, they are changing, but looks like not that much. I know that it changes here. So the question is, do I implement it, the backward path, correctly? So what I'm going to do, I'm going to stop for today. I will need to double check. I think the next time I will be debugging the all of the backward paths. It's actually not clear if it's a problem with the backward path or it's a problem with the forward path, because kind of the prediction is more or less the same. So the model still thinks that it's, I mean, it doesn't know which class it is. And I mean, right now it's clear, well, more or less, because if you, I mean, ideally, for example, for the first one, it should, this number should start growing, because first 100 samples are for the first class. Yes? Yeah. But they are not. We called initialization. It's actually interesting. We'll do this, and I want, you know what? Okay, the last thing I am going to check, and yeah, that's it for today. That's one wait. I'm curious how they're initialized. But I mean, I think there is no point to okay, they are pretty random. And here the weights are okay. I will stop for today. Clearly, I need to debug it more. And at this moment, I'm not sure if it's a problem with the data or it's a problem with, maybe it's a problem with my implementation, because I mean, the model predicts something, but I mean, the reason that I'm not sure, because it quickly, the predictions turning into the equal distribution. I mean, they're more or less equally distributed. I mean, the probabilities between classes. And I'm not sure why it's happening like this. So maybe I will actually be able to test it properly with a smaller network. We'll see, but more or less, until I fix the issue, I don't see a point to going further, at least until I debug it really, really good. I mean, maybe that's my point. Maybe that's the model started to go crazy, but I think it's, I mean, the accuracy is always pretty low. So it's like, in some places it started to predict the correct value, and on the other hand, it started to predict the correct value in another place. So on average, the accuracy is the same, around 33%. And that's what I see on the outputs for all of the samples. So this is kind of suspicious. Yeah, I need to think. I mean, I need to sleep. I need to think about this, and we'll continue tomorrow. But for now, see you next time. Bye-bye.